Today's lesson, we're going to talk about graphing other trigonometric functions. So last lesson, we did sine, cosine graph. And this lesson, we're going to do secant, cosecant, and secant, right? Also, we're going to look at the tangent and cotangent. When we're looking at cosecants, we know that cosecant is inverse of the sines. So pretty much what we're going to do is we're going to graph as the sine function first, and then we're going to find the cosecant's graph from the sine graph. Same thing with secant. So secant is inverse of cosine, so we're going to draw the cosine graph, right? Cosine graph. And then find the secant graph from that cosine. And this is the information you're going to have for domain, range, amplitude, and periods, and asymptotes, right? This is a information for cosecant. This is the information for secant. So let's look at the first problem here. We have y equals to 2 times cosecant 2x. In order to find that, your first steps, you wanted to find 2 sine 2x graph. And remember, sine graph, we can find amplitude is absolute of A, which is 2. And your period is going to be 2 pi over B. So that's going to give you 2 pi over 2, which is pi. And vertical asymptotes, we don't. Vertical asymptote is going to be 2 pi. No, this one will not have vertical asymptote. So let's see if we can graph the sine. So sine graph, it starts from 0, and your 5 points is going to be a period divided by 4. So that gives you, this is the period right there. So that's going to be pi over 4. And then when you plus pi over 4 to that, you're going to get pi over 2, and then 3 pi over 4, and pi. Start from 0, right? So it'll be, let's graph pi over 2, 3 pi over 4, and pi. And your amplitude is going to be 2. So that will be the first point, second point, 3, 4, 5. So your sine graph should be look like that. So once you have a sine graph, now what we do, your vertical asymptote for your cosecant is going to be this line. Every point when your sine graph is touching x-axis, right? And then your graph for 2 cosecant 2x is going to be from touching highest points of the sine graph and the lowest points from the sine graph. Right? So that's how you're going to graph cosecant. Start from the sines. Let's try another one. This time you will see secant. So inverse of secant is going to be cosine. So you're going to graph y equals to -3 cosine x over 2 first, right? And your amplitude is going to be absolute of -3, which is going to be 3. And your period is going to be 2 pi over b. That gives you 2 pi over 1/2. That's 4 pi. Period over 4. Let me write that 5 points from here. So period over 4 is going to be 5 key points. So that will be pi. And when you add pi to it, that gives you 2 pi. So start from 0 will be 0 pi, 2 pi, and then keep adding. Pi gives you 3 pi and 4 pi. So when you graph, it will be pi, 2 pi, 3 pi, 4 pi. Right? And starting from 0, and because you had this negative right here, it means it start from the bottom, and your bottom will be -3. The lowest points, right? Highest points will be 3. So start from here, going up, and going down back. So your cosine graph should be look like that. And if you wanted to find a vertical asymptote for your secant graph, will be all the places that your cosine touches x-axis, right? So it will be this and that. And your graph should be starting from here, going down. Let me make it wider. And from here, going up. And from here, going down. If you wanted to see one more point, so that you will have another vertical asymptote, that will be 5 pi, and that will be your vertical asymptote. So that will be another problem. And that's how we graph secant, starting from cosine. So understanding how to graph sine and cosine will guide you to graph your cosecants and secants. Now when we're looking at a tangents and cotangent graph, here is the information you need to know. And as you can see, tangent and cotangent have a similar shape, it's just opposite, right? That's how it's like cubic functions, right? But then cotangents start from the other side. And this is the information of the tangent, and this is the information of the cotangent. So there is two ways to graph tangent, cotangent. First method is finding the vertical asymptote by the formulas. So if this is the formulas, right? Let me highlight it. If this is the formulas, where you have a tangent or cotangent to the bx minus c, right? Then using the bx minus c in the middle, and this is the regular graph of tangent and cotangents, and start moving vertical asymptotes by solving in the middle for x, right? That's one way of doing it. The other one is using the graph. So when we're looking at this graph right here, you see that tangent, the standard form of tangents, you're going to have vertical asymptote from 2 pi and negative 2 pi and 3 pi over 2. And then your graph is between that and passing through the points in the middle, right? So they're passing through a point in the middle. So they're passing that point, that point. So it rotates. If it starts from the 0, there is a point on the 0. There will be vertical asymptote on the next pi over 2. The next is going to be the graph that is passing, and then asymptotes. When you're looking at the cotangent, that's opposite, right? So you're going to have vertical asymptotes on 0, 0, right? That's vertical asymptote, and then pi. And in between, you're going to have points that graph is passing by. So using that information, you can build the chart. And chart can be look like this. And if we're just looking at the tangents, you can see that this point right here, 1 over 0, 1 over 0, is going to be undefined. So we know that is going to be vertical asymptotes, right? And when denominator is 0, that's undefined. So again, that will be vertical asymptotes. And cosine will be, this will be vertical asymptotes. Cotangent, right? So if we have this, depends on what types of the graph you have, functions you have, you should be able to add and subtract from this standard 5 points. So that's the second way of graphing tangent and cotangent. So we will look at both way in a first example. So let's look at the first one. We have y equals to tangent x plus pi over 4. So compared to the standard form, we have tangent x before, right? That was the standard shape. Only thing different, we have plus pi over 4. So if we use the formula, remember we will have, for the tangents, b, let me write that formula since I don't want it to go back and forth. Formula was negative pi over 2 and bx in the middle and pi over 2 on the right side. So plug in that, right? And since we have c as pi over 4, if we replace that, we have x plus pi over 4 is between pi over 2 and negative pi over 2. And when we solve for x, we need to subtract pi over 4 from both sides. So subtract pi over 4 from both sides. what you get on the middle will be just x itself, because that cancel out. Have to have same denominator, so this becomes 4 to 2 minus 1 will be positive pi over 4. And this is going to be another 4 and 2, because you multiply numerator denominator by 2, and same sign, and when you add them it will be 3 pi over 4. So this value is going to be your first vertical asymptotes. So let's mark that. Let's say this is your negative 3 pi over 4, and this is pi over 4. And then we need to find in the middle of that 2 points. Why? Because this is going to be your vertical asymptotes of your tangent graph. And another one is going to be, let's see it right here, which is pi over 4 plus pi gives you 5 pi over 4. So that will be 5 pi over 4. So that will be another vertical asymptotes. So points in the middle of those two is going to be another x-intercept, right? And if we wanted to find this x-intercept, that's going to be negative pi over 4. We understand how to find the midpoint, right? Add those two numbers, so you're adding this two number, and divide by 2 to find the middle value. And if I work that on the side, it will be negative 3 pi over 4 plus pi over 4 divided by 2, right? That gives you negative 2 pi over 4 over 2. Multiply both sides by 1/2. To get rid of complex fractions, that gives you negative pi over 4, right? So that's how you're going to find the middle x-intercept. Oops. So now if we draw the tangent graph, it starts from on the right side going down the left side, right? Do that for the both. And that's how we're going to graph the tangent, given tangent functions. Another way of doing the same graph is using the chart that I was mentioning, this chart right here. So using this chart, we should be able to find the 5 points. So let me show you how I will do that. So I will do you have pi over 2, negative pi over 2, 0 pi over 2, pi and 3 pi over 2 if it was the standard tangent. But because you have x plus pi over 4, you're going to subtract pi over 4 from that 5 points. If you do that, you will get negative 3 pi over 4. Instead of 0, you get negative pi over 4, and you get pi over 4, and 3 pi over 4, and 5 pi over 4. And from this, we know that 2 pi over 4 was vertical asymptotes. 3 pi over 2 was vertical asymptotes. So this must be vertical asymptote also. And that's how we're going to get vertical asymptotes and x-intercept. So this is going to be x-intercept, and this is going to be vertical asymptotes. And you can see that from the graph also, right? Vertical asymptotes, and x-intercept. So you can either use the formulas to find the points, right? Negative 2 pi over 4, and you can either do one with the table. Let's try the B. Which is y equals to negative cotangents x minus pi over 2. Let's use the formula. So this is going to be x minus pi over 2 is smaller than pi or greater than 0. So what we wanted to do is trying to isolate x in the middle by adding pi over 2. All three sides. So in the middle, you will just get x, pi, plus pi over 2. Pi become 2 over 2, so this become 3 pi over 2. And that's going to be pi over 2. So if we wanted to graph that, it should be, so first tangent should be, so that's going to be vertical asymptotes, right? And this is going to be 3 pi over 2. And exactly half of those 2 points should be pi. And draw the vertical asymptotes. And this is going to be cotangents. So cotangent usually start from this side like this, right? But because you have a negative, it looks like a tangent graph. If you wanted to find one more, period, then this is going to become, this is pi, so this should be 2 pi. And right here should be 5 pi over 2. And that's another vertical asymptotes. And one more negative cotangent. We will go over all these examples in class, but because this is the lecture video, let me just do one more, well, 2 more. But let's do D this time. Like I said, if you wanted to see examples that we don't do it here in this video, you need to come to the class to watch it. So if we look at D, which is y equals to 3 cotangent 1/2 x. This time, let's see if we can do it with the table, right? So if we're looking at the table right here, the basic table for cotangents is started from 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we know that 0, pi, and 2 pi was the vertical asymptotes, right? So we're going to use that basic. So let me draw that basic points, which is going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And what are we doing it here? We're going to multiply this by 2. Why? right here, 1/2 is multiplied to x. So in order to get rid of that 1/2, you're going to multiply by 2, right? So that's the reason you're multiplying by 2. If you multiply by 2 of these 5 points, you will end up getting 0, pi, 2 pi, 3 pi, and 4 pi. And remember, the same vertical asymptote location will be the vertical asymptotes. So this is going to be vertical asymptotes. So how do we graph it? Let me just plug in all those values. Pi, 2 pi, 3 pi, and 4 pi. And then vertical asymptote with the red. 0, 2 pi, 4 pi. And this is, which one was it? Cotangent, right? Cotangent, so start from left side up and right side down. Left side up, right side down. So that's how you're going to graph. Y equals to 3 cotangent 1 over 2x. So the other ones are very similar to what we've been doing. It's just becoming a tangent, right? So let's see. I'm going to do the last one. Last one have more to work on, right? More value is attached to variable x and tangents. So let's try that one. So we're looking at G. Y equals to 3 tangent pi x minus pi minus 2. So let's get the tangent points. Tangent points, the standard shape of tangent, we had 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right, I'm going to compare it right here. Right, 0, 2 pi over 2, pi, 3 pi over 2, 2 pi. And we know pi over 2 and 3 pi over 2 was vertical asymptotes. So remember that, right? And let's see what we need to do from that point. So what you need to do first, because this negative pi, you're going to, in order to get rid of that negative pi, you're going to add pi. So let's say from here to here, you're going to add pi. And when you add pi, what did you get? Pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. That's what this does, right? Negative pi. What about this pi? Well, in order to get rid of multiplication pi, what do? We are dividing by pi. So one more step. And that will give you, dividing by pi will be 1. This is going to be 3 over 2, 2, 5 over 2, and 3. And don't forget, your vertical asymptote was this, right? Vertical asymptotes. So when you're graphing it, it should be 1, 3 over 2, 2, 5 over 2, and 3, right? Let me just mark all that points. But then also you have this. So that means you're going to go down 2. Let's go down 2. So that will be the points. Let's mark the vertical asymptote. And what does this 3 does? That's going to be the stiffness of your lines. So actually you will not be able to show that well. So that's going to be points, right? Going down from 1 going down 2, from 2 going down 2, from 3 going down 2. And this is going to be positive tangent, so right side up, left side down. Right side up, left side down, right? And that's how you're going to get your graph for tangents and cotangents. So it's up to you how you want it to do it. Again, you can either do it with the formula, or you can do it by the 5 points. Right here, formula, right? You can use the formula or you can use the 5 points. It's up to you.